Welcome to this example Solid Mastermind training video for Solid Edge with synchronous technology. Solid Mastermind is the complete online resource for all of your Solid Edge training needs and support questions. In the next few minutes, you will see a short example of the type of Solid Edge training material available to members of Solid Mastermind. This preview is part of the surfacing training and covers the use of the KeyPoint Curve command. The KeyPoint Curve command allows a 3D curve to be created by selecting points in 3D space. We can select key points from existing geometry in the model, or we can select in free space, or we can enter specific XYZ coordinates. In addition to this, we can also control the end conditions of the KeyPoint curve and define tangency relationships with existing geometry. To illustrate the KeyPoint Curve command, we'll open example 8. As you can see, this model contains some existing solid geometry, which we will ultimately use to help us create a KeyPoint curve. First though, we'll create a KeyPoint curve in free space. When the command is started, the command bar will provide the steps and options for selecting key points or defining coordinates. Also, a triad will appear on the screen. The triad can be used to restrict the plane or axis for the key points that define the curve. For instance, if we select the XY plane and then start to create the KeyPoint curve, all of the points will lie on the plane parallel to the XY plane. If we create another KeyPoint curve, and this time select the X-axis, all of the points we use will be in line with each other and parallel to the X-axis. If required, we can change the axis or plane during the creation of the curve simply by selecting the triad as shown. Some useful shortcuts for this are as follows. X will cycle through the planes on the triad, Z will cycle through the axes, and C will clear the plane or axis lock. For now, we'll hide the curves we've just created. Now we'll create a curve between the corners of the solid blocks on the screen. We'll start by picking the left-hand block on one of its corners. Notice the endpoint glyph next to the cursor. We'll then identify a point in free space. Remember, at this time it is possible to use one of the planes on the triad to restrict the position of the free space point relative to the point we've already selected. Then to finally finish the curve, we're going to pick the right-hand block, but instead of identifying the corner point, we'll pick an edge close to the corner point. We can see the difference because the edge highlights as well as the corner point. We'll then hit accept to create the curve and finish. When inspecting the curve closer, we can see that the end of the curve is tangent to the edge we selected, whereas the start of the curve is not tangent because we picked a specific endpoint or vertex rather than an edge. If we wish for the start of the curve to be tangent to, we can edit the curve definition, then access the end condition step. This allows us to change the start condition to be tangent. The edge that the curve is tangent to is shown in green. Since there are 3 edges associated with the point at the start of the curve, Solid Edge may or may not have picked the desired edge. This can easily be rectified by simply selecting the appropriate edge. In addition to this, the green glyph on the curve represents the tangent magnitude. This can easily be adjusted by clicking and dragging on the glyph. We can even change the tangent direction if required. The tangent magnitude value is also displayed in the command bar. Also, the select point step allows us to redefine existing points or to add new ones. To add a new control point for the curve, we simply need to hold down the Alt key on the keyboard and then select the curve where a new point should be added. We'll add 2 to this curve. To redefine or move any of the points for the curve, we can select the Redefine Point command from the command bar, then select the point we want to move. As we do this, the point will turn red. We can then move back onto the point and drag it into a new location. The triad once again helps in restricting the directions in which the point can move.